So I'm going to get started as soon as possible, not to waste any time. And I'm going to start the session by quoting Paul Maritz, former VMware CEO. And he said, cloud computing is not about where you do computing, but rather how you do computing. And this is fairly important for the talk today, because what I want to show is that there is a way to do cloud computing cost effectively and easily. And the main reason why I chose serverless as the topic is the number one reason I hear that people don't build anything at home anymore is cloud's too expensive, my credits are done. How do I get this home project or even a client's project up on the cloud and not get billed at the end of the month to kill my card? So to get started, what is serverless? Or even before that, just a little bit about me. Name's Reuben Kruger. I am a developer at Investec Bank. And then I'll dive in. So what is serverless? So serverless is a cloud computing model where the cloud provider basically manages everything for you except your own code. You are responsible for your code and only your code, and the rest is out of your hands, making things a little bit easier on your end. So like I said, provider responsibility, they'll manage the service for you, and it frees you from the actual maintenance of those servers, and I'll get into more detail for that. And then the term serverless, I want you to kind of rephrase the term serverless in your head, and instead of saying serverless, which kind of sounds like there's no servers, hence the clickbait title, Death to the Server. Instead of saying serverless, I want you to rephrase it as serverless. It just means that your involvement within the server is nullified. You are responsible for the code that you put on the server, but the server itself is out of your hands. So there's 4 main pillars of serverless. The first one being, like I mentioned, zero infrastructure management. You don't have to do anything on infrastructure. Serverless is inherently event-driven. I'm not going to go into design patterns too much. I'm happy to talk about it afterwards. But third one, it's pay as you use. This is probably the main point I want to illustrate today, is serverless is very cost-effective. And the reason for that is they charge you on CPU and memory usage as you use it, but you don't pay any pre-provisioned costs. Hence why it's cheaper. And then effortless scale. I'll touch a little bit on the effortless scale, but I won't go into too much detail. But serverless is super easy to scale. So if you need more horsepower, you set the rules and it'll scale for you. You don't actually have to go and scale those servers. So some alternatives to serverless that everyone's used to. So you've got your own hardware. That photo is a data center rack I've got under my stairs, and the family really does not like it, because it's bigger than the fridge. And when it comes to this hardware, I'm responsible for everything. When it comes to hardware, software, operating system, everything is managed by me. Then the second one, virtual machines, everyone's favorite. But everyone knows virtual machines can become expensive very quickly. And it's a pain to maintain these things. If you've got 1,000 VMs running and you have to patch images, it's a nightmare. Third one, your traditional web apps. People use Azure will know web app. Super easy to set up, but one mistake can cost you a lot of money, because you've got all of these little, this full list of different types of servers. You've got P1, V3, and whatever. And if you choose the wrong one, $8,000 a month, it's not going to be fun. And to scale these web apps is a bit more difficult than serverless, and I'll get to that in a while as well. And then the fourth one is containers. But containers is heavily dependent on how you host these containers. So for example, if you host the containers on serverless, it'll be cost effective, but if you go and run some massive Kubernetes scale and you forget the wrong setting, or if you do something wrong, again, $8,000 bill at the end of the month is not going to be fun. So what do all 4 of those, services have in common? They are expensive. In this graph, which is almost accurate to the point, serverless runs at about 10% of competing costs for everything from VMs to web apps, especially VMs, and Kubernetes clusters, self-managed Kubernetes clusters. But then you also have to remember that there's a human cost to it. So to maintain VMs is not just expensive for the VM itself, but someone has to maintain it. So that's going to cost you more money anyway. Where with serverless, the only thing you pay for in the human factor is the developer's code that has to go onto the serverless app. Then we can see how this costing thing plays conceptually if we look at how services scale. So if you think of everything that's not container apps, if you need to scale something, you would have your initial node. If you use all of its resources and you don't have any horsepower left, simply just add a second one. But it doesn't mean you're going to use that second one to its full capacity immediately. Eventually you will, then you'll add a third one. But now you're paying for 3 servers pre-provisioned. So if you add 2 but you don't use the full 2, you're still paying for the full 2 servers constantly. And that's where the cost racks up. So where does serverless then come in? That little squiggly line. It's not a constant. Because container apps is built purely on CPU and memory usage as you go, even if you scale up to 10 container apps, if you use all of your resources, you still only pay per use. And the scaling makes a massive difference, because if you can scale, another benefit to container apps is you can scale to 0, where with any other service, I know some of the cloud providers do give you that functionality on different services, but this is simple. I mean, container apps can scale to 0 on a bunch of different topics. For example, if you've got no HTTP traffic for the last 10 or 20 minutes, scale to 0, it'll cost you nothing. So even though the resource technically exists, if it's scaled to 0, you pay 0. A good example, at the end of the talk, there's a QR code where you can actually rate any speaker today. And I spoke to the organizers, and that service runs on a container app, and it cost them less than $1 for last year in totality. Because what they do is when it's not used, scales to 0, and it just chills. You don't pay anything for it. So with serverless, you just basically avoid all that upfront overhead. And I'll show that in a little bit. So how do we actually scale serverless? I'm not going to go into too much detail, but if you know Ghetto scaling, same concept. You can do everything. For example, I'm mostly an Azure developer. So with Kida, you would actually set that up in Bicep, deploy the Bicep, and everything's managed for you. You've got HTTP scaling rules, custom rules. You can scale on service bus usage, memory usage, CPU, whatever you want to scale on. Kida allows you to scale on it. Where with something like function apps, you would have to build your own little scale controller. It's a bit more difficult, but it's still fairly easy. So where can you actually get started with serverless? So the 2 main providers in the country are still Azure and AWS. I know Google has got their offerings, and there's a few different ones as well. And I'll happily share these slides in the end if anyone wants to go through these. But both main providers do give you 1-year free tiers. Container apps, for example, on the Azure side, is not necessarily supported just on the free tier, but for life, it's free, or it can be free if you scale it properly. Where with function apps, as long as you're under 1 million requests a month, it's free. On the AWS side, I'm not too familiar with the AWS side. They've got their offerings as well. And then on the demo I'll show in a while, I used Service Bus as well. Service Bus supported by the free tier, and even outside of the free tier, it costs very little unless you push massive traffic through it. I'm not using Cosmos for the demo, but also Cosmos, if you use it right in a serverless way, so as soon as you deploy Cosmos, you've got an option to actually run Cosmos as serverless. A lot cheaper than running it pre-provisioned. Then looking at how you actually architect software for serverless, everyone's used to monoliths. I believe everyone here has touched monoliths at some point in their life. And the main drawback of a monolith is nothing can be scaled independently in a monolith. Once you want to scale anything inside that monolith, you have to scale the whole thing. And obviously, that's not super efficient. After monoliths came the whole push for microservices, where we took domains out of the monoliths, deployed them separately, and now you can scale them separately. But what happened after microservices is serverless. So now, instead of deploying domains on themselves, or domains by themselves rather, you can now take each function within your app and deploy that separately and scale them separately. What this allows you to do, for example, if you know you're handling way more emails than WhatsApps on your comm servers, you can go and scale email independently from everything else, which will cost you less. The whole point is it's going to cost you a lot less if you can scale stuff more granularly. And then the other benefit is if anything in your app fails, everything else will still run. So you've got that that separation of fault domains. And then again, serverless is platform as a service, so you only put your code there. That's all you have to worry about. Even when you go and create the managed environments on something like a container app, you don't get to choose the horsepower behind it. You don't get to choose anything. You just have to give it a name, deploy it, and then you can put your containers on there. You then decide, I think the only thing you decide on is CPU, which is a weird metric. It's usually like 0.25 CPU, whatever that means, and then RAM. But you can also change that on the fly and then scale as you need. This is a nice little graph to show how, with time, the developer's involvement within the tech basically boiled down to just code. So for example, that data center under my stairs, I'm responsible for everything. If a SAS drive fails, I have to find one, buy it on Takealot or whatever, put it in, I have to update everything. I have to maintain everything on that cluster. Where with something like serverless on the far right, all of that's managed for me. I just put my code there and I forget about it. Then I built a small little demo to more or less show what can be done with serverless, and it's both a video and I'll do a quick Visual Studio demo on how to actually deploy these things. So the demo itself is fairly simple. I took my Investec developer bank card. I can actually write code on the card, deploy it to the card. And then as soon as I go to a McDonald's or anything unhealthy, and I tap that card, it's going to send me a WhatsApp and an email to tell me, stop it. Don't do that. But I believe everyone, and I don't know how well you'll see it, knows what an ESP32 is. So this is one of those 8266 modules with a screen. And I've got one sitting right under my PC screen. So I thought, no, why not get the message there so that when I sit down at my computer, it also tells me, stop it, don't do that. And with monoliths, everything in this picture would usually sit in one unit, but I can't scale it. Not that I would scale, I don't buy that much McDonald's, I promise. But to scale everything separately would be a nightmare because everything's contained in one. But with serverless, for example, the orchestrator, email adapter, and the WhatsApp adapter are all separate services. So if I need to send a lot more WhatsApps than emails, I can scale it accordingly. But so how do I add this little IoT functionality? Well, simple. I just develop another adapter connected to the service bus, done. I don't have to go and maintain other code. I don't have to write services in my monoliths. Nothing. It's separate service. You can have shared libraries, of course. That's all up to your software architecting standards. But now I've got the ability to tell myself to stop it on a little screen under my PC. So then I'm going to try and show, hopefully if the demo allows me to, how to do this in Visual Studio and how easy it is to get something up into container apps. So in this example, you'll see the stuff I put in the picture. So I've got the email adapter, the WhatsApp adapter, now I've got the little IoT adapter. The code's not nice, don't judge. But all it does, listens to service bus. When a message comes through off of a topic, just execute the adapter. And that adapter would be either email, WhatsApp, or now IoT. And to get this onto Azure, what I can show is this. So let me just get out of here. So on Azure itself, I've got a few resources that I just set up manually. So I didn't do any fancy infrastructure as code or none of that because I'm trying to keep this as simple as possible for you to go home and to get that home project started up again, thrown on the cloud and hosted for next to nothing. So on Azure, I've got a few things. So that container apps environment's the actual environment that you'll deploy the containers to. To set that up takes about 3 minutes max. It's just a few things you fill in, some naming, and it's done. The container registry is important because usually when you want to deploy something as a container app or even function app support containers, you put it on the registry and then just publish it to the relevant service. I've got my email adapter, the orchestrator, my service bus namespace, API management because container apps, as soon as you deploy a container, it gives you some random URL. And if you deploy something again, it gives you a different random URL, so it's fairly hard to keep track of. But as soon as you do APIM, it gives you a nice little way, and I'll show that quick, to go and add your container apps onto APIM and expose a known endpoint. I'm sure everyone knows what API management does. But But as soon as you have a container app done, there's a little connector built in to APIM to go and add the container app. You would browse and just select the name of the container app you just deployed, and it'll do everything else for you. It will pull up the endpoints, it'll create the Swagger docs, everything's done for you. So that's fairly simple. But there's no IoT adapter here. I've got the IoT hub set up, and I've got my WhatsApp adapter there, but I've got no IoT adapter deployed yet. And how easy is it to do it? Well, if I go to the IoT adapter project, it is as simple as out of Visual Studio going to publish. Again, I'm not going language specific. As long as it runs in a container, you can run it in a container app. I'll go and add a publish profile. I'll select Azure, container apps. It'll ask me if I want to use an existing one when it loads. But I've got no IoT adapter, so I'll create a new one. It usually does all the naming for me, but I usually just take those out. Everything's selected, create that, so that'll run. So this will actually go and create the ARM template, send it to Azure, deploy it, and it's done. Then, when you actually want to deploy the code, after this is done, you'll see like a publish button, hit publish, and your code's up. It's less than 3 minutes to get existing code up on the cloud. This is without scale rules, but you can set the scale rules fairly easily. On Azure itself, when you deploy a container app manually, you've got the options to set scale rules. Out of Visual Studio, you don't. With Bicep, you do. With ARM templates, you do. So there's a bunch of different ways you can do that. And while that's busy running, I will show a video quick of me actually running this off of my card. So with Investec Developer, you've got a nice little portal where you can simulate card transactions. So what I did for the first video is you'll see email's empty, WhatsApp's empty, and the IoT device just tells me the Wi-Fi is connected. I'll go into the portal and simulate an actual McDonald's transaction. And as soon as that goes through, and I'll show the code on the code that I've deployed to the card now, that'll send a request to my orchestrator. It'll determine is this healthy or not, should this guy be eating McDonald's. And then I'll get email, WhatsApp. You'll see the emails there, so it's telling me to try greens. I'll get a WhatsApp, same thing, try greens. And then on the little IoT device, short of it, oh, McDonald's. Just a little guilt trip. And then the second video is me actually at the McDonald's for the 4th time testing this, scanning the card. And you'll see within a few seconds on WhatsApp, as soon as I tap my card, it's again going to tell me I'm making bad choices and I should stop buying McDonald's. And there we go. And that'll then be on my email when I get home and on my PC screen. So I should probably stop buying McDonald's. So what does the actual code on the card look like? Super simple. It just does an API call, takes a transaction, sends it to my orchestrator. The orchestrator will actually run that through AI and then determine is McDonald's a good choice or not. Build up a nice little sarcastic message, send it to my adapter topic, done. Then I'll leave the floor open to any questions. So the question is, will I actually get rid of my data center rack? No, because it's cool. It draws more power than anything in my house, but there is stuff you cannot run on serverless. A good example, everyone's probably played with home lab stuff. If you've got Proxmox running and you've got some media center running, it won't be a good idea running that on 2 gigs of RAM. So the DC is mostly content. All it does now, none of my actual at-home apps, so for example, Home Assistant, all of that stuff, all of that's running on container apps. But serving media, so my media center runs on the DC. Everything else I moved over to the cloud. So I actually got rid of a bunch of my servers within the rack. So now I've got a 2.5 meter rack with 3 servers in it. There was another one.
You spoke about CADA when setting up scaling rules. So when you do it, so if you've got like a lot of individual functions, do you have to set up those scaling on an individual setup for each function, or is there like a way that you can group them to say this set follow this particular set of scaling rules?
So scale rules are usually per container. So if you set up the scaling, if you do bicep, for example, so if you deploy your code and you do your IAC with bicep, you can just share that actual module and do it across, but usually it's on a per container setup. So each container will scale separately. So for example, the orchestrator that I had is a typical HTTP endpoint, what they call minimal API. There I would put in, for example, an HTTP scaling rule, but then my adapters are all service bus listeners, so worker services. They will be service bus scaled. So it won't necessarily be the same rule for all of them, but if you need a rule on all of them, you'll have to do it on each one of them, yes. So it's not a shared rule, it's per actual app.
I have another question. Is there a way to encourage moving from microservices to individual function? And by that I mean, is there an easier way that you can migrate or have like some of your functions, some of your microservices be migrated into functions? Is there tools to encourage migration, if you will?
So again, if you've got a traditional app and you have to move to functions, it's a bit more difficult. But if you want to just containerize it and run it serverlessly, it's a bit easier. But that all depends on how the software was architected from the start. So if you architected it in a way that you can split it up fairly easily, it's not a big move. And then the actual reason that you would want to do it is just mainly cost savings and just ease of getting it anyway. So another thing that I actually mentioned in the talk, as soon as you containerize something like a minimal API for container apps, that app can be moved to almost every provider. Where with something like function apps, you lock down to Microsoft, where with something like container apps, it's a Docker image. So you can run that on-prem, AWS, Azure, Google, wherever you want to. So it all depends on how that software was built in the first place, and that'll basically answer the question of how easy it is. But for container apps, in Visual Studio, you just right-click, add Docker support, done, and you're ready to go to container apps.
Okay, you're making me ask other things now. So you mentioned this thing it runs on a platform as a service, right? So if that's the case and you're saying you're paying for the resources as you consume them, are we saying that you cannot have it as a hybrid setup? So you cannot have like your database sitting on your premises server and then the function app sitting on Azure?
You can. So if your code itself caters for connecting to on-prem, 100% you can split them.
And the usage of it, is that what the function is consuming on the cloud? That's what you pay for?
So what you pay for is just the resources the actual function is using. So anything externally from the function has zero impact on the cost. I think the main driver behind the cost is how you scale. So if you unnecessarily scale and just hammer the thing, you'll pay a lot more. But if you do scaling in the right way, it'll cost less. But anything outside of that, so for example, I mentioned Cosmos DB. So you'll be built on Cosmos as a separate instance and your apps as a separate instance, but it's usually that managed environment contains multiple apps. The managed environment is what actually charges you in the end, but it's just for the actual container. If you ran a DB in a container on a container app, then it'll be charged as container app, if that makes sense.
Yeah, it does. Does anyone else have questions? Because I can go on forever.
All good.
This question. So if you put your app on a serverless setup, but it's using external database, charge for the traffic?
No. So again, with container apps, CPU usage and memory is the only thing you charge for. Everything else is ignored. So CPU usage, memory usage, pay as you use, that's it. That's all you have to worry about. Where with something like function apps, if you, for example, have a managed environment, P1, V3, you'll pay that fixed cost for the whole month. But with container apps, it's purely just CPU and memory usage, that's it. I can't speak to AWS's side, but I know for Azure, it's purely just CPU and memory based.
Thank you.
Go for it.
Okay. So my only concern with container apps is typically startup time. You know, when you start up your server, if it's Java server, it might take a while. Depending on what it is, it can take a few seconds to start, right? And then if it took a few seconds to start, and now it executes that one query, and now it shuts down. The performance impact of that's maybe a bit concerning. So I'm not sure. What's your opinion of that? How do you choose whether using that versus function
So
is better?
the nice thing is, so I'm very used to bicep, but I know in Azure you can set it up that way, so you don't have to scale to 0. You've got the option. So if you tell it to scale to 0 based on these rules, it'll scale to 0, you won't pay anything. I know Container Apps still has the fastest cold start out of any other service on Azure at the moment. And it's usually sub-second. It's usually measured in milliseconds, but I know in some systems, milliseconds is everything. I mean, I know Azure did a whole push where they did inter-DC connection into nanoseconds now because people want that. So to answer your question, if you are concerned about cold starts, just don't scale to 0. But even if you've just got one instance running, it's going to cost you a lot less than having one web app, for example, running, or even function apps. I do believe function apps can also technically scale to 0, but you still pay a pre-provisioned cost for that managed environment. With container app managed environments, you don't have that cost. It's purely on what you use. So if you've got one instance permanently running, but it's consuming barely any CPU or memory, the bill's going to be negligible.
I just wanted to find out for the vertical versus horizontal scaling. So you've mentioned you have items or you have instances that are spinning up and then spinning back down. So you have one single instance running at 0. Has there been a cost-effective analysis between horizontal and vertical scaling for those things?
So the direct answer is I'm not sure if there was an analysis done, but to give a bit more context on the scaling, so Container Apps only basically does the horizontal scaling. So for example, when you spin up your managed environment, you've got 0 choice on hardware or anything. There's nothing you can set on a managed environment to differentiate it performance-wise. But when you actually spin up the container, it gives you that weird little CPU metric where you choose, oh, I want 0.25 CPU, whatever that means, and 2 gigs of RAM. I think the limit is still 2 gigs of RAM and 1 full CPU, or it's actually 2 CPU and then 4 gigs of RAM. But how they manage the scaling is then horizontally just add more instances instead of scaling up, I guess, the hardware. Because scaling up the hardware, you can only go up to that 4 gig RAM, 2 CPU, whatever. But you can't go higher than that. But then again, you've only got a certain pool that you can use within one container app. And then you'll get into the whole multiple revisions. There's a lot more detail that I'm trying to avoid just to make it simple. But you can go look at running multiple provision versus single provision, where you can actually run, more of your blue-green deployment, stuff like that. But to answer the question, there's no vertical scaling. It's all just throw more instances at it, and it should solve the problem. Cool, then I think that's a wrap. The QR code is just a link tree, bunch of stuff. If you want to contact me, more than welcome to. If you want to follow me on LinkedIn, I've actually got a link on there if you want to join us. If you want to see what programmable banking is about, there's a link for that as well. And then please, if you can, the bottom link is to actually rate speakers. It's for all speakers, including me. Highly appreciate it if you do. That's what I've got for you.